Well, another day has passed and a little bit of internet research, and it's amazing how smart you get. Or less ignorant. It would probably be a better description. All right, so I cleaned this thing up, and I already knew this was marked TRW. And what I learned is, well, let me start by saying there is a number here. It says patent pending, and then there's a number right here, and it says HGA 012999. Now, the important thing to realize is that this is not the part number for this steering valve. That is a part number, but it's probably the part number for this casting of this main body right here, and just that part. The actual part number on these valves typically is on this section right here, this neck part. Not up here, but here. And oftentimes it's covered with rust, paint, grease, whatever. So by cleaning this up really well, I was able to find a number clearly marked right here, stamped on here, HGA 10013. So that is the correct part number for the whole assembly. Then there's a space, and then there is a 025, and then a space, and then a 3. That information there is a date code, but it doesn't quite jive with what I found online, so it's not really going to be able to tell me much. But it's quite possible that it means that this was manufactured on the 25th day of 1973. That kind of tracks with this being a 74 tractor. It's completely believable that this is the original valve, and that it was the valve was produced in 1973, shipped, went to a factory, and eventually went into a 1974 tractor. So that's what I think we've got going there. TRW has some sort of relationship as far as corporate entities go with Ross and also with Parker. And I don't know if that's the same Parker as Parker Hannifin or whatever, but I believe it might be. So even though it only says TRW on here, there's a definite relationship between TRW, Parker, and Ross. Steering component manufacturers that either at one time or another, either one owned the other, or there was mergers, or for whatever reason. But a lot of the information you'll find on this valve today is actually available through TRW or Parker's websites. Now that we know that this is an HGA with that number, what that means is that this is of course we already saw on here also, let me back up for a second. Remember we saw this right here? Hydra Guide? Not Glide, Hydra Guide. So this is a Hydra Guide steering valve. There are different series of Hydra Guides. This is the HGA series of Hydra Guide. The first two digits in that long number, the 10, it tells a lot about the makeup of the valve and everything. So there is a company called Midwest Steering. I have no affiliation with them. They don't give me anything for saying it, but they apparently are a very good go-to source for information and parts and repairs of these valves, because they have a really nice spot on their website where they talk about identifying your valve. They also talk about that they have a replacement valve that will take the place of this valve, and it's supposed to sub a whole bunch of valves in the HGA series. The layout of the piping is a little bit different. Instead of having it, you see how this is kind of staggered? Instead, it's more of a square. Instead of a trapezoid like this, it's a square, and they're basically in line with each other, so you might have to do a little fussing to get all of the hoses to get on the thing, but they basically saying that'll work. It also has this type of input shaft, which I think they call this the pinhole type, because it's got a hole with a pin that goes through it. But then I found a really nice website that has a downloadable PDF service manual for these valves. And I was reading through that last night, and turns out one of the things you're not supposed to do is you're not supposed to bang with a lot of force to get this pin to come out of here, because there's a needle bearing right behind here that supports this end of the shaft, and that can be damaged by doing what I did. Now, I'm hoping that I didn't damage it, because you may remember I wasn't just banging it without supporting it underneath here. I had the block underneath here supporting this. So we'll find out. There is a Ford part number for this whole assembly. And I don't remember what the Ford part number is, but it doesn't matter, because if you look up the Ford part number, it's like $1,500 or $1,800 for a replacement valve assembly. If you look up the HGA number here and go direct to the manufacturer, it's like $1,000 for a new one. And if you go with the more generic replacement, that HGA 10, I think that's around like $600 or $700. Clearly what you want to do is you want to go with as direct to the source as you can. There's a parts breakdown on the Ford New Holland website that actually shows a lot of the seals and everything in here as separate components that can be purchased. And one of the most expensive seals in this whole thing is actually not up here where you would think it would be. It's actually a large band type of seal in this section right here. Midwest Steering has a kit that has this expensive seal and the other seals and O-rings you need for this model for like $98.50. And they actually say that they realize that that's actually more money than you may be able to find those parts for in other sources. But what they're saying is that their parts are sourced, that their parts are made in the USA and top quality. And that it's the same kits that they use in their shop when they get one of these for rebuild. And they do a rebuild on one of these, because they also rebuild these steering units. So they're basically saying, yeah, we stand behind our parts, so we're going to ask a little bit more money for them. So $98.50 for that kit. I am going to do a little more research and figure out what I'm going to do when it comes down to the wire. But right now, what I want to do is I want to get a look at what I believe is the culprit. In my case, is this seal that's in here. It's actually a packing, like a hydraulic cylinder. So the manual that I found actually talks about that if you want to replace this seal, not to take this assembly right here off of here, not to take these 4 bolts out and take this off. What they actually suggest you do is that you actually remove the retaining clip that they say is in here. And then once you remove the dust seal, which is that thing that I pulled out of here that looked like snot, and then remove the retaining clip, which I'm going to have to see if I can see that. And then to get those seals out, if it's still in the vehicle and it's hooked up to the hydraulic system, you can actually use the hydraulic pressure to actually force that seal to push out. And then they say if that isn't possible, if you've already got it out of the machine, what you're supposed to do is you're supposed to cap 3 of these lines and then hook up air pressure to one of these lines and rotate this, and at some point air will push it out. But then I read further on in the manual where it talks about if you're disassembling this further to do wear measurements and things like that, that you can take this off. And so if I'm going to take this off anyways, I'll probably just take the seal out that way. Yeah, it's a snap ring in there. All right. Oh, interesting to note that unlike the bolts that I took out already, which are hex head, these are not, so you need a multi-point socket on these. So water in the hydraulic system. That is the reason why that's so bad. It's because that can lead to corrosion and pitting of these critical hydraulic components. Well, I'll tell you what, listen to that needle bearing. Sounds a bit gritty. So it appears as though the needle bearing rides right around here. So I'm thinking this area right here that looks really cruddy is where that seal is supposed to ride. So that's not good. Well, I'm going to want to try and clean up and resurface this shaft to see whether or not I'm going to be able to reuse it. So I'm going to take this assembly out. So I'm going to start by standing this back up. So it occurs to me I should have taken better care to note what orientation this was on in case it's critical. It doesn't look like it matters which way this goes on. So there are a pack of shims, 4 shims, and then we've got another retaining ring right here. So I'm going to pull this straight up and out very carefully because there may be balls or something in here. And there's just this collar. There must be a way that this shaft disengages from this spool. There appears to be some sort of a special clip right here. Well, the good news is the spool valve itself actually looks like it's in pretty good shape. I don't see any really bad signs of pitting. Of course, wear limits, stuff like that, I'm not going to be too concerned about that. My thinking is just see if we can get new seals in this thing to stop the leak, because when it wasn't leaking out the fluid, it seemed to be doing the job that it's supposed to do, which is steering the tractor. All right, let me set this off to the side for a moment. Turn my attention back to this assembly here that has the seal in it. And that seal appears to be pushed in there. So, question is, can I press that seal out from the inside here? If I press the needle bearing out, that'll push on the seal and push the seal out, but I really don't want to remove the needle bearing if I don't have to. Then again, it really, at the very least, it's going to need to be really well cleaned. I wonder if I could just grab this with a seal puller. So there's a part of the seal, and then like a wavy washer and a packing. It's really not much to this thing. And that is just, the stuff that's in there is like dirt. I can feel the grit. It's a horror show, and that's all what's in that needle bearing. All right, okay.